Welcome everyone to the first lecture of the third week of Unit 1 of the Introduction to Data Science module. Today we're going to be talking about writing code in good Python style. And we'll be using this Pythonic notebook in your data course Python directory. So we'll go ahead and open that up. You've maybe heard me say the word Pythonic before, or you've maybe read it online. And what the word Pythonic means is that some bit of code is written in good Python style. That's what we mean by Pythonic. It exemplifies the values of the Python programming language. So you might be asking yourself, how can a programming language have values? How does it have particular things that are emphasized or encouraged? Well, every programming language has a particular syntax and a particular approach to how programs are written, based on things like can functions accept other functions as input, are variables statically typed, are the data structures, are there mutable data structures? And also syntactical elements like, does every line need to end with a semicolon? And these decisions that get made when people are designing a programming language can emphasize particular styles of programming. So for example, there is a language called Scala, which is related to Java, and Scala is what's called a functional programming language. And in functional languages, data is typically regarded as immutable. So most of the data structures in Scala are immutable and statically typed. Functions return definite output for each unique input. And that's partially enforced by type safety. Functions must declare what types of variables they accept and what they return. And some languages also include more or less syntactical markers denoting different contexts, the termination of lines, things like that. So Python's choices along these different lines inform certain values we should hold when writing Python code. We'll talk about that in more detail in just a moment. To give you a preview of some of the other things we'll be discussing in this notebook, we'll be talking about the modularity of the Python language, which is one of its key features, as well as how the Python interpreter gives us information about our own code in the form of exceptions and how we deal with those when we're debugging code. So let's move on to examine what this idea of Pythonic means. If ever you're wondering what are the values that Python has, we can always import this, which is not displaying for some reason. There we go. So import this prints out the Zen of Python. And this is a short list of some of the most important things that we encourage when writing Python code. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And if you read through these, you'll eventually encounter readability counts. And a lot of the rules or values in this short document relate to readability. For instance, it's easier to read an explicit expression than an implicit expression. If something is written out explicitly, I can read it. If it's left implicit, then I have to sort of read between the lines and think about what the programmer's intention was. It's easier to read something that is simple compared to something that is complex. It's easier to read something that is flat rather than nested. It's easier to read something that is sparse rather than dense. Python strongly encourages readability. One way in which it does this relative to other languages are by using white space as a syntactical marker. So for instance, in some programming languages, for instance, languages in the Java family, a function definition might look sort of like this. I declare some function. This part might even be something longer. I haven't written Java in a very long time, and I don't remember exactly the syntax for declaring functions or defining functions. So there might be a bunch of stuff specifying the scope of the function, for instance, before the function name. In some languages in the Java family, you have to say what kind of variable, what type of variable or variables are accepted as arguments. For instance, we might have a list called numbers. And we also might have to say what kind of output this function returns. Maybe this function returns a list. And then we would have our function body enclosed by curly brackets. And we might say, for instance, for index in range len numbers. Let's see. We might have something like this in some kind of Java type language. And of course, in Java type languages, we're supposed to end our lines with semicolons. So there's a lot of markers here. These brackets, these semicolons, that are to some degree visual clutter. They distract my eye from what I'm trying to read. So one way in which Python improves readability is by using white space as a syntactical marker. So I don't have these semicolons or brackets distracting me from trying to read the contents of the function. Likewise, certain declarations are a bit more aesthetic, say. Lists are contained by square brackets. Usually when we create a list, we just contain it in square brackets. It's a very minimal notation compared to the word list. The word list is maybe a little more explicit, but anyone in the habit of writing Python code has seen these square brackets millions of times. When we evaluate a list, it's represented to us enclosed in square brackets. So we can easily see this as an empty list at a glance. And it just looks, the code ends up looking much cleaner than many other languages. So that's one way in which readability is somewhat designed into Python by using white space as a syntactical marker for a function context or the body of any context, for instance. Another example of Pythonic style, this flat is better than nested idea. We can even clean up this for loop to be one-line comprehension if we want. So we could shorten this function to just return 10 times number for number in numbers. And this is very elegant. And when I introduced comprehensions in the first week of lecture, I talked about why comprehensions are so elegant and why they help readability. We say exactly what we're going to be doing during each step of our iteration, rather than putting this in reverse, where we would say, okay, I'm going to iterate over something, and at each step of the iteration, I'm going to do this thing. Comprehensions put the kind of action first. They say, we're going to do this for every this. And that expression, that kind of ordering of the ideas, more closely follows how we would normally express such an idea in English. So comprehensions read a little bit closer to English than traditional for loops. Another way Python streamlines readability is we iterate through the elements of an iterable directly. We don't have to think about creating some index and then indexing into a data structure. This is a lot of conceptual overhead. Reading through this function, we say, okay, I have a function that accepts a list of numbers. We might even have to have here like list, float, declare what kind of thing is inside the list. So in something like Scala or a Java, related language, we might have to say, okay, I'm going to make this empty a list. Why? I don't know yet, but it's going to hold my output. And then I say for every index between 0 and the length of my input numbers, okay, I've forgotten all about output now. Now I'm on to this iteration. What am I going to do with this iteration? Oh, well, I'm going to append something to the output, and I'm going to append 10 times the number at numbers index. It's much harder to explain what's going on here because I keep switching between different names and ideas, and I have to think about indexing into a data structure, whereas in Python, I just iterate directly over the elements, which allows me to give very, say, straightforward names when iterating. For number in numbers. That's, for each number in my list of numbers. It's very close to the normal expression in English, as I would explain this code. So that's some ways in which readability is designed into Python. Before we move on to other topics, I want to call attention to a few other values in Python in this Zen that I think are particularly important and don't have to do with readability. One is that errors should never pass silently unless explicitly silenced. A lot of beginning programmers don't appreciate this idea or don't appreciate error messages. They tend to view error messages as a problem rather than a tool. So let me give you an example of why we should want to have errors be raised when something goes wrong rather than allow them to silently fail. So I might be running a internet store, an online store, and I might have many users. So I have, and these users have a purchase history. And we'll just have user A who bought, 10, 4, 6. These are just like amounts of, or like amount of money they spent over their past several purchases. So we have these users who are spending some amount of money, and we also will say, there's some function purchase, which takes a purchase history and a new purchase, or a user and a say cost or price. And we're going to basically take this history and we're going to add at our user, we're going to append the new price. And if we if user A comes along and purchases a new item for $8, that's perfect. Their new purchase was recorded into their purchase history. If I have a new customer, customer D, and they buy something for $16, I encounter a key error. There is no key D in my purchase history. And you might encounter this and say, well, what I really want to do is add a new customer, customer D, and create a new list and append that purchase of $16 to it. This key error is getting in my way. So you go back and you say, you know what, I'm going to modify this purchase function to say, if user in history do this, else history. Oh, actually say, we'll do it slightly differently. We'll say, if user not in history, we'll initialize an empty list for the new user. And then in any case, we'll append this price to that user's purchase history. And now, I can add that customer D, no problem. Here's their purchase for $16. And this is fine, but for one possibility of where this could go wrong is we might need other information about the user. We might need their name, their address, their billing information, so that we can actually charge them for a purchase. It does us no good to update the purchase history if we don't have the customer's information. So rather than allow this to sort of pass through unnoticed and just add this user, we might want to raise this error to call attention to the fact that there is a new user. And then we could do something like prompt them to create an account. So there are many times where we need to know something has gone wrong. And error messages are an excellent way to draw our attention to where our code is failing. It's much worse to have code fail silently and then we get results of our program that don't make sense or that we think are true, but in fact there's some hidden bug that is making our results erroneous and wrong. So raising errors explicitly can be very important, unless we expect to encounter particular errors, in which case, if we have conceptually accounted for this instance where there is a new customer in our store, if we've already accounted for that, then it's fine to do something like this. That's an instance of explicitly silencing an error, because we've already handled it. We've already handled the problem. Another important value that I want to emphasize, and then we'll wrap up this one. Actually, there's two more that I want to emphasize. In the face of ambiguity, refuse the temptation to guess. As we encounter more complex data structures and objects, as we introduce new new packages in Python for doing data science, we'll encounter a lot of ambiguities. Ambiguity tends to go hand in hand with complexity, and complexity is often required for kind of additional power, additional analytical power. So as we get access to more powerful tools, we'll encounter more ambiguity. And the thing that we tend to do in Python is defer to the user. Excuse me. Whenever ambiguity is present. We don't presume to know what the user wants to do. So we try to avoid guessing what the user wants to do, and instead require the user to explicitly state what they want in the face of ambiguity. This is somewhat related to this idea of having errors come up explicitly. Or explicit is better than implicit. We always want to be sure that we know exactly what we intend to do and have that intention explicitly expressed in the code. And then another value I'll touch on, because we're going to talk about this in a moment, is namespaces. Namespaces are related to the idea of scope that I talked about earlier, and we'll be seeing more of them when we talk about import statements. I'll talk a bit more about namespaces then, but they are really valuable for organizing our code, and they are very, very helpful. So the very last point in the Zen is namespaces are one honking great idea. Let's do more of those. So I'll elaborate on that in the next video.